Good morning. It's my pleasure to be here in beautiful city of Vienna and listening to some great speakers about the subject that I'm beginning to realize how difficult it is. As an IT person, we tend to go fast, we tend to go high volume, and we tend to go full speed. But here, I feel like I'm in a marathon race. So let me start to do a little bit of video. So when we joined autonomous discussion earlier, about 3 years ago, we decided to acquire HARMAN so that we can get into really the automotive industry, as well as also being able to bring audio experience, which is two major technology and business they had. It really helps us, Samsung, got into the business of really thinking the technology of semiconductor to mobile phones and using those technologies and being able to apply that into automotive industry that we believe is going to be smarter, connected, and electrified. So those are the mega trends we're looking at. And let me just give you IT perspective, and then I'll give you our perspective of how we see autonomous going. So the first of all, where we are today is obviously all these discussions are happening because of the technology innovation that happened from computing to internet to the mobile era. And now we are in the convergence era of all these things coming together to make our lives better and being able to have a better driving, better health, and other convergent technologies. And to talk about this, I want to give you perspective around where we were, just kind of looking back. And when I first started my career, really the PC was just beginning. And if you compare the time where we are in today, almost 40 years later, you can see the technology progression. In some ways, the amount of the transistor density that was in versus where we are talking about 100 billion transistors in your chip that are being designed without going through every transistor being tested. But yet it works when it comes out first chip. It wasn't like that in the beginning era of this personal computer time. It happened through many discussions we talked about. Standardization, process technology, simulation, verification, validation. So all those things we're talking about did impact a better compute, and all these things are becoming fundamental elements of where we live. I would also say that if you look at even the phones, right? If you look at the left side, right side, Goldie Gecko in a movie called Wall Street, I believe, and the phone was really expensive, really heavy. You couldn't do text messaging. You could not have any multimedia. It was just text messaging. But today, obviously, we are all using smartphones, and it's helping all of us better connected. In some ways, we're also getting addicted in digital media. So there's some sides of good and bad. But in overall, I think it does impact all of us better connected with more data. In a process where I cannot even have a debate with my kids in the dinner table because they have their information on their fingertip. So it is a very interesting time we are living in. So in that convergence era, where are we going? And it is clear that the IT has improved and contributed for a better connected world. More than 50% of the world now have internet access. There are over 8 billion mobile phones being used around the world, which means there are more phones that are used than number of population on Earth. Along with that, we also introduced some of issues that are coming. Particularly, as an example, every one of us here talked about security risk, safety. Clearly, if you look at number of security breaches, it's increasing. And it's a major concern that all of us we should have as things are more connected and more digitalized and easier for hackers being able to target your lowest device that are in USB connection for 50 cents coming from somewhere. That could be the source of your breach, right? So we have to really think about safety and the robustness of the nature of the business we are in a connected world. So with that, I think that this technology has proven we can live much better world. And because of the evolution in semiconductors, all the way to sensors we talked about earlier, how important that is. And we're not talking about lidars, radars, cameras. I'm looking at things that can be able to measure heart rate variability, being able to measure glucose, being able to measure blood pressure. All those things come together, a GPS, all those things come together, we can really impact not only driving, but also health and other convergent eras. So I think it is a very exciting time that we are in. Frankly, what we are all doing together is not just going to impact better driving. I think it's going to impact all of us live better with better robotics, better technology that are just part of us. And how do we navigate that is the era that we are in. So I would say that our autonomous era is not about driving. We're talking about how we are living going forward. So future of mobility and services, therefore, in my view, is going to be gradual. It's going to take time. It is a marathon. And it's going to take a lot of money. And I think the game just began. And I believe a lot of things we learned in IT, just like what happened 30 years ago, 40 years ago in the computer era, is just adopting and applying all those things together. I think we can have more innovations and ideas that can be able to impact our lives. So what do we bring then from IT to future mobility? So I was thinking, Klaus talked about the cars, and we talked about other standardization issues. So I don't have a lot to add in autonomous subject by itself, but I can give you perspective and lessons we learned from IT industry as we progressed and as we built a very massive industry that are impacting our lives. So mobile 1.0 for Samsung is about phones. And I think that mobile 1.0, the smartphone, would not happen unless we all work together as an industry. If you remember some years ago, when you have a phone from Japan, you could not use it in Europe. If you had a GSM phone and taking to US, some part of US you could not make it work because GSM and CDMA, all the different standards have to come together, becoming A1. If you take a phone to China, it could not make work because there's slight different standardization going on there too. So industrial fragmentation have to really come together to make it as one. And also think about Bluetooth, where you're connecting things today, granted, that wasn't around. And as well as Wi-Fi and others. So all those things made great experience that we carry in your phones. Some of us, I guess, sleep with that. I don't recommend it, but it happens. And the batteries, where it's now lasting more than a day, where you don't have to worry about your usage. So the question is that what is mobility 2.0? And I realized at Samsung, when we say mobility, we talk about mobile phones. But I think in this room, when we say mobility, we talk about something else, right? We're talking about this, the subject of how we move, transport, urbanization to helping us to move around the area. So we were looking at this subject and realizing how complex the system that we are dealing with. Obviously, I talked about mobile 1.0, where we have to agree on certain protocols, We have to agree on certain way of network. We have to agree on certain battery standard. We have to agree on certain architecture that can be able to use. We have to agree on API that can be able to download certain apps. That was mobile 1.0. But here I'm realizing we need to figure out how to get our infrastructure to work with us. So it's not just an OEM issue. It's not just the semiconductor supplier issue. It's not a tier 1 issue. It's a common issue that we are embracing that are really an important journey from regulators to innovators to startups, and incumbents have to work together to navigate that. And it's a very complex system problem that are not easy to solve. So I'm really happy that TT Tech and Ricky Hudi and others put together this event because I think it requires, to solve this complex issue, we need different people coming from different backgrounds working on these problems. And this is why I believe the more I study, the more I'm realizing we're going to have a long marathon that are coming up. So the other thing that I'm realizing, like what happened in IT industry, it did not happen with a small heart and small investment. To build a fab, it requires $10 billion per fab. And to build a chip today that are in large amount of application processing power, it requires $100 million. So anything we do today is really expensive. And when I look at some of the requirements that we're talking, it's even more expensive because you have to put it all together and it better be working. So in IT, you have a volume to pay for that. If you don't have a volume, you really cannot afford to have 10 billion fabs or $100 million chip projects at a time. So what we need here is also, if you don't have a huge volume, then we need to figure out how to get paid for the projects they're working on. So I see there are multiple headwinds in front of us as we are going into in this industry that requires massive investment. And I think that, I don't know, it's hard to quantify what that is, but looking at the even 5G that we are investing, we are committing a lot of money into that infrastructure, but that's just one piece of it. Batteries. To meet all the battery requests we're hearing, it may require $50 billion worth of investment. So just one company alone. So we're looking at really massive investment required to play a what I call smartphone type of technology migrating into the future of mobility, along with safety and security that are required. So we are in an unknown territory that requires a massive investment and massive collaboration. And obviously, when you look at just the traditional sense, the building blocks seem simple. There's an OEM, there's a tier 1, there's a component supplier, there's an IP provider. That blockchain, the process doesn't change. But when you look at the details, there are a lot of companies out there. It's a very complex ecosystem. And if you don't manage it, we can have a different standard, different approach, and different protocols. And it'll be a massive miswaste of resource that requires some kind of approach that makes sense. And traditionally, if you look at the operating at scale, also requires, like batteries, requires massive deployment to support that. So we got another infrastructure issues on the top of building ecosystem issues. These are the kind of complexity I believe that we have to figure out how to manage. At the same time, if you look at the companies like Samsung, what we're trying to do is we're not trying to solve all problems. There's no way we can. We're going to focus on where we're good at. We are the largest semiconductor company in the world, so we'll make good chips. Chips that can be able to scale, chips that can be able to support the multiple application need, and chips that can be able to extend over time. We'll work on sensors that make sense for us to develop, where it makes like imaging sensors and others that apply what made great smartphones. And also being able to work on 5G infrastructure. That's something we've been committed. So to do that, we have committed $160 billion worth of R&D dollars next 3 years. So that's the almost $50 billion R&D dollars that are spent on the top of your, what I call the capital expenditures. And we also we've been working with a large number of startups to encourage innovations that are coming from startups, because I think startups can really disrupt a lot of new ideas, like Innovium in Israel, that are working on new kind of LiDAR sensors. And there are many companies like that. I don't know whether they're going to be successful, but what we're trying to do is encourage innovations and work with them. And in the process, we believe we can be able to play piece by piece and being able to work on certain approach. With TT Tech, we actually, as you may know, we've been with Samsung investing in TT Tech as a way to create a collaborative future. And we actually developed this driveline platform as a way to create a reference platform to help us to learn about this market, not as a way to market it, but to learn about what we don't know. Because as a newcomer with a lot of IT knowledge, but very low safety and autonomous knowledge, how do you catch up? You work with the partners, and that's what we are doing. We're creating a metal would be the more hardware side of that, liquid would be more middleware side of that, and then air would be more cloud and data side of it, and that's work in process. And some of the things that Matthias can, I'm sure, talk more about later. I can also say that it's really important when we are developing our system on chip, we need to make sure the chip that are using can be extendable so that your software, your hardware can be scaled over long term. And these are the examples of what we're trying to commit with our community. And it'll take some time, but we're still learning. And I would say we're very early stage of investment. And we are trying to do baby steps at a time, try to embrace autonomous because we see this as a long haul, a long game. I think that our lessons we learned from IT industry is eventually the one that has a staying power, that can be able to invest long term, that they can be able to work with the right partners can win. And so I feel like we are in a round one of the game, that we are in this round of a very difficult journey, but very exciting journey at the same time that are in front of us. What are other things we learned from that? I think the things that we learned from the past is really about standardization. And many people talked about that, so I don't re-emphasize the importance of it. But it's really clear that we cannot have everybody creating their own versions of stacks from the OS to the platform, and then being able to developing its own simulation, to validation, all that scope will create a redundant investment as well as the friction and complexity that may be not very helpful in making progress. So how do we go about doing that is still a question mark. I think today, the great news is we all agree on common issues. I hope this afternoon and others can work on how do you solve those issues? How do you make progress? How do you become industry problems we can be able to address as a group? And how do you make sure it's a profitable venture? It's not clear to me how that's going to happen overnight, but over time, I believe we can get there because autonomous is going to become very important function, not only for automobiles, but for robotics. And anything we do is going to require these functions and sensors that we are developing for many other applications. So I do think that because of these, it's really important we think about open innovation and we collaborate, and it'll require massive investment, which means what I learned from IT industry is that in many ways, we're not going to have a lot of players. It will be what I call consolidation of players to make the ROI make sense, to make the standardization effort happen. In a way, if you think about mobile phone industry, there were many companies that played mobile, but at the end of the day, if you think about today, there are only really 3 companies that has over 65% market share, and only 3 companies that are profitable in the whole world of making mobile phones. So it is kind of if IT industry any indication of what it takes to get where it is, then the future of the outlook is that it will be highly discriminating industry unless you have a clear differentiation to make your products unique. But yet, because of massive investment that are required, massive standardization it requires a force and power and volume to drive an industry going forward. Thank you.